Dynamic source routing. It is a routing protocol for wireless mesh network. It is similar to AODV. However, it uses source routing instead of relying on the routing table at each intermediate devices. Determining source routes require accumulating of the address of each device between the source and the destination during route discovery. The accumulated path information can be cached by nodes processing the route discovery packets. The learned paths are used to route packets. To avoid using source routing, DSR optionally define a flow ID option that allows packets to be forwarded on a hop by hop basis. This protocol is truly based on source routing, whereby all the routing information is maintained at mobile nodes. It has two major phases, which are route discovery and route maintenance. Route reply would only be generated if the message has reached the intended destination node. To return the route reply, the destination node must have a route to the source node, which is very obvious. So if the route is in the destination node's route cache, the route would be used. Otherwise, the node will reverse the route based on the route record in the route request message header, which require that all links are symmetric. In the event of fatal transmission, the route maintenance phase is initiated, whereby the route error packets are generated at a node. DSR is an on-demand protocol designed to restrict the bandwidth consumed by control packets in ad hoc wireless networks by eliminating the periodic table update messages required in the table-driven approach. The major difference between this and the other on-demand routing protocols is that it is beaconless and hence does not require periodic hello packet beacon transmissions, which are used by a node to inform its neighbor of its presence. The basic approach of this protocol during the route construction phase is to establish a route by flooding route request packet in the network, and the destination node on the receiving a route request packet responds by sending a route reply packet back to the source, which carries the route traversed by the route request packet received. Each route request carries a sequence number generated by the source node and the path it has traversed. A node, upon receiving a route request packet, checks the sequence number on the packet first before forwarding it. The packet is forwarded only if it is not a duplicate route request. There are many cases where the duplicacy is possible. The sequence number on the packet is used to prevent loop formations, and to avoid multiple transmission of the same route request by an intermediate node that receives it through multiple paths. So all nodes except the destination forward a route request packet during the route construction phase. A destination node, after receiving the first route request packet, replies to the source node through the reverse path the route request packet had traversed. Node can also learn about the neighboring route traversed by data packet if operated in the promise node. The mode of operation in which a node can receive the packet that are neither broadcast nor addressed to it itself. This route cache is also used during the route construction phase. This protocol uses a reactive approach which eliminates the need of periodically flood the network with table update messages, which are required in a table-driven approach. The disadvantage of this protocol is that the route maintenance mechanism does not locally repair a broken link. Stale route cache information could also result in inconsistencies during the route reconstruction phase. The connection setup delay is higher than in table-driven protocols. temporally ordered routing algorithm, TORA. It is a source initiated on demand routing protocol. It was invented by Vincent Park and M. Scott Carson from University of Maryland in 1997. TORA is a highly adaptive, efficient, loop-free and scalable routing protocol based on link reversal algorithm. The main objective of this algorithm is to limit message propagation in the highly dynamic mobile computing environment. It supports multiple routes to transmit data packet between source and destination nodes of mobile ad hoc network. In short, TORA exhibits multi-path routing capability. This algorithm operations can be compared to that of water flowing downhill towards a sink node through a grid of tubes that model the routes in the real world network. The tube junctions represent the nodes and the tube themselves represent the route links between the nodes. And the tube's water represent the packets flowing between nodes through the route links towards the destination. TORA works in three main phases: route creation, route maintenance and route erasure. Route creation from source to destination, route maintenance, it's maintenance of the route, erasing of the route when the route is no longer valid. TORA contains quintuple metric that consists of logical time of link failure, unique ID of node that defines the new reference level, a reflection indicator bit and propagation ordering parameter and unique ID of the node. Hybrid protocol. Hybrid protocol attempt to take advantage of best of reactive and proactive schemes. The basic idea behind such protocols is to initiate route discovery on demand but at a limited search cost. One of the popular hybrid protocols is zone routing protocol, which is called ZRP. Zone routing protocol is a hybrid of reactive and proactive protocol. It was invented by Zygmunt Haas of Cornell University. ZRP divides the network into zones of variable size. Size of the zone is determined radius of length. In other words, we can say that the neighborhood of the local node is called routing zone. Specifically, a routing zone of the node is defined as the set of nodes whose minimum distance in hops from the node is no greater than the zone radius. To create a routing zone, the node must identify all its neighbors first, which are one hop away and can be reached directly. When a source node sends data to destination which is not in the routing zone, the source initiates a route query packet. When the node receives this query, it adds its own identification number to the query. A big advantage of this scheme is that a single route request can result in multiple replies of route, and the source can determine the quality of these multiple routes based on such parameter as hop count or traffic and choose the best route to be used. The differences between the wired fixed network and wireless network open up various interesting challenging topics such as interference, regulation and spectrum, low bandwidth, high delay, lower security, shared medium and ad hoc networking. And these protocols always help to establish better network with good throughput.